Hi students, welcome to Methodology classes. In today's lecture, we are going to discuss MCQs based on the circles. In this lecture, we have taken questions only based on the properties of the circle and tangents. You will get one or two questions from this topic. The questions will be easy if we remember the properties of the circles and tangents which are given in class 10th. So let's start. So the first question is, AB and CD are two chords of a circle intersecting at P. Choose the correct statement from the following. So if we see the options, so there are the relation is similarity between two triangles, and the left hand side is like in the left hand side of each similarity we have only triangle ADP. So we have to find out that triangle ADP, if we is this triangle, so we have to find out ADP is similar to which one of these triangles. Okay, so let's try to find out, like if we see triangle ADP, so we can see that angle P is vertically opposite to angle CPB, and AC is a chord. If we see, AC is a chord and it is subtending two angles D and B at the circumference on the same side of this. At the circumference on the same side of this. So we can say that angles in the same segment are equal. So these two angles will be equal. Choose a different color just to make the things more clear. So these two angles are also equal. So we can see triangle ADP, if we see triangle ADP will be similar to, so angle A is equal to angle C and D is equal to B and P is equal to P. So triangle ADP is similar to triangle CBP. So we can see option D will be correct. So this was a question based on just the properties of the triangles, that angles in the same segment are equal, and if two chords are intersecting, so vertically opposite angles will be equal. So in triangles ADP and CBP, we saw that angle P is vertically opposite in both the triangles, so that will be equal, and angle ADP will be equal to angle CBP because they have been subtended by the same chord AC. So they are angles in the same segment, so they will be equal. So we got two angles equal in two triangles, so the triangles will be similar to each other. Let's move to the question number 2. So question number 2, in the given figure, tangents PA and PB to the circles center at O from point P are perpendicular to each other. So PA and PB are perpendicular to each other. If PA is equal to 5 centimeters, so this is 5 centimeter, then the length of AB. So we have to find out the length of this AB. So PA is 5 centimeter. So this is an easy question based on just the property that tangents from a point outside to the circle are equal in length. So if PA is equal to 5 centimeter, PB will be also 5 centimeter, and we can say triangle APB is a right angle triangle. Right angled triangle. So if it is a right angle triangle, we can use Pythagoras theorem in this. So that's said PA square plus PB square will be equal to AB square. Now PA square is 5 square plus PB square is 5 square is equal to AB square. So we can say 2 times 5 square is equal to AB square. So if I take the under root, so AB will be equal to 5 under root 2 centimeter. So that will be the length of the chord AB. So this was an easy question. So we use the concept that length of the tangents from a point outside to the circle are equal in length. So PA was given 5 centimeter. So from there we inferred that PB will also be 5 centimeter. And triangle APB was a right angled triangle. So we used the Pythagoras theorem and found out that AB square will be equal to 2 times 5 square. So that is 5 root 2 centimeter. So moving to the next question, question number 3. In the given figure, AT is a tangent to the circle centered at O. If angle CAT, so CAT is given 40 degree, then angle CBA. So CBA is this angle. So CBA has been asked. So now we know a property of the triangle that angle formed by the tangent and a chord of a circle is equal to the angle subtended by the chord in the alternate segment. So in the alternate segment. So CAT, so chord CA is subtending 40 degree as with the tangent AT. So AC is a chord, so this is the segment. So angle in the alternate segment means angle ABC will also be equal to 40 degree. So that will be the answer, option D. Now if you don't remember this property, then also we can arrive at the answer as BA is a diameter of the circle, so it will be perpendicular to the tangent. So this whole angle will be 90 degree. Now angle CAT is already 40 degree, so this portion will be 50 degree, 90 minus 40, and angle ACB is angle in a semicircle, and we know angle in a semicircle is 90 degree. So this is 90 degree. So angle ABC will be 90 minus 50, that is 40 degree. So we got the answer 40 degree. Maximum number of common tangents that can be drawn to two circles intersecting at two distinct points. So if two circles are intersecting at two distinct points, how many tangents we can draw to them? So let me draw two circles. So this is a circle and this is another circle. They are intersecting at two distinct points. So it is asking how many direct common tangents can be drawn. How many common tangents can be drawn means a line which is tangent to both the circles. So if we see, let me choose different color. So if we see, we can draw a tangent like this, which is tangent to both the circles, and a tangent like this, which is tangent to both the circles. Now we can't draw any other line which is touching both the circles at the same time. So we can see, we can draw only two common tangents to both the circles. So option C will be our answer. Now moving to the question number 5. In the given figure, so this is the figure given, if PT is a tangent to a circle with center at O and angle TPO is 35 degree, then measure of angle XS. So this is 35 degree. Now if this is 35 degree, we know OT is radius and PT is a tangent. So radius is perpendicular to the tangent at the point of tangency. So angle T will be 90 degree. So we can see that this plus this, suppose we assume Y, so Y plus 35 degree should be equal to 90 degree. So Y will be how much? 90 degree minus 35 degree. So 90 minus 35 will be 55 degree. So Y is 55 degree, but Y plus X will be equal to 180 degree because they form a linear pair angle. So Y is 55 degree plus X will be equal to 180 degree. So X will be how much? 180 minus 55 degree. So 180 minus 55 degree will be how much? 125 degree. So option D will be our answer. So if we go through the question once more, it was an easy question just involving two properties, that radius is perpendicular to the tangent at the point of tangency. From there we inferred that angle T will be 90 degree. Then we used the property of angle, some property of a triangle, that sum of the three angles of a triangle is 180 degree. So from there we found out that value of y will be how much? 55 degree. Then we use the property that y and x forms a linear pair angle, their sum should be 180 degree. So from there we got x will be 125 degree. So option D will be our answer. Now let's move to the question number 6. In the given figure, O is the center of the circle, MN is chord, and the tangent ML at point M makes an angle of 70 degree with MN. So the measure of angle MON. So this value we have to find out. Now, as discussed in the one of the previous problems, that if a chord subtends any angle with the tangent, then the chord will subtend the same angle in the alternate segment. So if we draw this angle, so this will also be 70 degree. So this is 70 degree. Now we know MN subtends angle 70 degree at the circumference. So MN will subtend double of that at the center. It means this will be how much? 140 degree. So option B will be our answer, 140 degree. Now if you don't remember the alternate segment theorem, so we can use another concept also. OM is a radius, so it will be perpendicular to the tangent at the point of tangency. So from there we can infer that this angle will be how much? 20 degree. Now OM and ON are two radii of the triangle. So if angle OMN is 20 degree, then this angle will also be 20 degree. So if this is 20 degree, this is 20 degree, so MON should be 140 degree to satisfy the angle sum property of the triangle. So option B, 140 degree will be the answer. Question number 7. In the given figure, AB and AC are tangent to the circle. If angle ABC is 42 degree, then the measure of angle BAC. So this angle we have to find out, BAC. And this is a very easy question. So we know that A is a point outside the triangle and two tangents have been drawn from A to the circle, AB and AC. So AB and AC will be of the same length. So triangle ABC will be an isosceles triangle. So this angle will also be 42 degree. So now sum of angle B and angle C is 42 plus 42, 84 degree. So angle BAC will be how much? 180 degree minus 84 degree. So that will become how much? 96 degree. So option A, 96 degree will be our answer. Now question number 8. In the given figure, QR is a common tangent to the two given circles touching externally at A. The tangent at A meets QR at P. If AP is 4.2 centimeter, so this length is 4.2 centimeter. Then the length of QR we have to find out. So this is a very simple question. We know that tangents from a point outside the triangle are equal in length. So PA and PQ are two tangents to the left circle. So they should have the same length. So this will also be 4.2 centimeter. Now again PA and PR are two common tangents to the right circle. So this will also be 4.2 centimeter. So from here we can say that QR will be 4.2 plus 4.2, 8.4 centimeter in length. So option C will be our answer. So this was a simple question based on the concept tangents from a point outside to a circle are equal in length. Now moving to the next question, question number 9. Question number 9 is a simple question. You can try this by your own. If you will have any issue, you can just write in the comments. Now let's move to the question number 10. In the given figure, RJ and RL are two tangents to the circle. If angle RJL is 42 degree, then the measure of angle JOL. So this angle we have to find out. Now again, as in the previous question, RJ and RL are two tangents from a point R outside the circle. So these two angles will be equal because RJL will become an isosceles triangle. So this will also be 42 degree. Now as in the previous question, angle R will be how much? 180 minus 84, that is 96 degree. Now we know the angle formed between two tangents and angle subtended by the chord joining the point of tangency of the two tangents at the center are supplementary to each other. So we can say that angle R plus angle O is equal to 180 degree. So angle R is how much? 96 degree plus angle O is equal to 180 degree. So angle O will be how much? 180 minus 96, that is 84 degree. So 84 degree is our answer, option B. Now question number 11 is a easy question, but it is a little bit interesting. So at one end of a diameter AB of a circle of radius 5 centimeter, so there is a circle and there is a diameter of the circle and at one end A of a diameter AB of a circle. So suppose this is A, so we can draw a tangent. So this is A. At one end A of a diameter AB of a circle of radius 5 centimeter. So this is the center O. Tangent XAY. So this is XAY is drawn to the circle. The length of the chord CD parallel to XY and at a distance of 8 centimeter from it. So we have to draw a chord which is parallel to XY and it will be below the center because the distance it has been drawn at 8 centimeter and 5 centimeter is the radius. So it has been drawn at 8 centimeter below the tangent. So this should be 3 and this is 5. So the length of the chord CD. So we have to find out the length of the chord CD. So if we join O, the center of the circle, to C, so OC will be the radius. And we know radius is perpendicular to the tangent at the point of tangency. So this will be 90 degree and CD is parallel to XY, so this will also be 90 degree. Sum of the angles on the same side of the transversal and within the parallel lines is supplementary. So this is 90, so this will also be 90. So we can say angle or triangle OC, and suppose this is E, is right angle triangle. So right angle triangle, so we can use Pythagoras theorem in that, and hypotenuse is 5, one of the side is 3, so other side will be 4 because 3, 4, 5 is a Pythagorean triplet. So if CE is 4, so ED will also be 4 because perpendicular from the center bisects the chord. So 4, 4, so the length of the chord will be 8 centimeter in it. So what we used in this question is perpendicular from the center to a chord bisects the chord, and as the distance of the chord CD from XY was 8 centimeter, so OE will be 3 centimeter and XAY, the tangent is perpendicular to the radius, so CD will also be perpendicular to the radius. So this became a right angled triangle and hypotenuse was known and one of the side was 3, so the other side has to be 4 because 3, 4, 5 is a Pythagorean triplet. And CE is 4, then ED will also be 4 because perpendicular from the center to a chord bisects the chord. So the total length of the chord will become 8 centimeter. So I hope you would have enjoyed the session and your doubts would have been clear. If there is any problem, you can just message me in the comments. So till then, practice and practice. We will meet in the next lecture with the questions from the statistics. Till then, practice and practice, because practice makes a student perfect.